Hey everybody, we are group 112 and our project name is To Be or Not To Be.
In our project, we are creating an AI-powered computer vision for automated bee behavior detection.
Today, behavioral studies of bees are mostly done by manual observation. This takes a lot of time and is hard to scale. Our goal is to help biology researchers by building an automatic system that detects bee interaction and dominance behavior directly from the video.
During the process, we realized that instead of classifying complex full-length videos using machine learning, we can focus on identifying the interactions. So our MVP uses a flow of object tracking combined with distance-based rules to decide which bee is more dominant. First, we detect when two bees come close to each other and define this as a start of an interaction. Once the interaction started, we mark the middle point between the two bees. Then we wait until the bees separate beyond a defined exit distance and compare how far each bee moved from the interaction point. At this point, we can determine which bee was the dominant one in the interaction and which one was what we call the subordinate. The bee that moves away more from the starting point is the subordinate, and the bee that stays closer to the interaction point is defined as the dominant bee. This simple rule allows us to infer the dominance without having to deal with complex logic or training a machine learning model.
Here we show you a demo of our system. You can see the tracked bees. While the line is gray, we are in the idle state. Then the interaction is detected and we have a green line. Finally, we get the dominance decision at the end of each interaction. This is our current MVP. Okay, so up until this point, we faced several technical challenges. The first challenge we faced was the bee recognition part, the ability to recognize individual bees through the different frames. When using object recognition models that we trained ourselves, we faced a problem of identity loss whenever bees got into awkward positions that made them lose their bee shape. The second challenge was the movement recognition. We tried using classic object tracking models, but again, we faced a problem of identity loss, this time during intersections between the bees. And so, to solve these problems, we moved to barcode-based identification. The barcodes allow us to keep a stable BID across frames and significantly improve tracking reliability. That's how we come to our full tracking system. In addition, we needed to create interaction definitions, defining correct entrance and exit distances to avoid false positives, adding a cancellation mechanism for long idle states, like sleeping bees, and handling decisions about the system behavior regarding temporary loss of barcode visibility. And finally, to evaluate our system, we compare the algorithm results with manual annotations made by the researchers. We first measure dominance outcome accuracy. We also evaluate interaction detection using precision and recall, and analyze results using a confusion matrix.
And now for our remaining tasks and challenges. First, we want to improve detection precision and reduce false positives. We also want to support interactions with 3Bs and more crowded environments. This requires better differentiation between real dominance interactions and other approaches. In the future, we want to scale the system in different ways. This includes more petri dishes, more bees, and a wider range of behaviors. The big dream is to expand the solution to general bee videos, no number limitation and no petri dishes. For now, the real limitation of the current system is that we don't consider the direction the bee is facing. Two bees can be close, but not really interacting. And so we plan to use existing tools to detect fine movements such as antennae and wings to be able to further advance our system and even detect other complex behaviors of the bees.
And finally, here we wanted to give you a small glimpse into a possible future advancement using sleep. In this video, you can see the identification of the antennas of the bees. We plan to integrate this ability into our system in the near future. Thank you for listening. Itamar and Matan.